In this lesson, we're going to start with some foundations for right triangle trig. So before we start talking about some trig ratios, we have to start with labeling the sides of a right triangle. So it's going to be important to know the different labels here. So we have two different situations, and it's all going to be based on an acute angle. So for this first one, this right here, the A, we're going to call this the reference angle. So that's going to be where we're basing everything off of. So I'm starting at this angle here, and the side opposite that angle, so basically going across, is going to be called the opposite. The hypotenuse will always be the side across from the right angle. That'll never change. That's always the longest side. And then adjacent side is the side that's next to the angle. Adjacent really means next to. So if I look at that acute angle, next to it is the adjacent side. Now this symbol here is called theta. So that's something that you're just going to see a lot in trig. It's just like another variable. So it's just like an x or a y. It's just we use it a lot to represent angle measures. If I look at the other side here, now if I'm saying that this is my reference angle or this is my starting point, the opposite side changes, because if I go across from angle B, that's going to be the opposite. The adjacent side is next to B, and it's the side that's not the hypotenuse. So the hypotenuse is technically adjacent to this acute angle, same thing here. But the hypotenuse always has its own name because it's the longest side, and it's the one that's across from the right angle. Where the adjacent side is the other side that's next to that acute angle. So for the first thing here, let's look at this triangle, and we're going to start with labeling the triangle if we use angle A as our starting place. So if I'm starting with angle A, I'm just going to circle that. I'm going to draw my arrow. So the opposite side would be right here. I'm going to end up erasing these two. So this is going to be the opposite. So the side of the triangle opposite angle A is going to be side CB, or BC, same thing. And then the adjacent will be the side that's next to the angle, but not the hypotenuse. Remember, the hypotenuse is always the longest side. That'll always be across from the right angle. So the adjacent would be this side right here. So that's going to be AC. So when you're labeling the sides, it's always going to be with respect to the acute angles. You'll never use the 90 because the 90 already has the hypotenuse as its opposite side. So the next part here says using angle B. So angle B. So what I'm going to do now is I'm just going to erase this. I'm going to start over and talk about angle B. So angle B, go across from angle B. That's going to be the opposite. So that's going to be AC. And then adjacent to angle B is the side next to it. So not the hypotenuse, but the side next to it. So this is going to be the adjacent side. So this is going to be CB. So notice how these are equal. So the opposite of one angle is the adjacent of the other acute angle. Same thing here. The adjacent of angle A is really the opposite of angle B. So that's going to be important to kind of remember for future. And then the other part here is just asking for angle C. What's the opposite and what's the adjacent? Let's just cross these off because I don't really like saying for angle C, because the opposite of angle C will always be the hypotenuse since it's the right angle, and the adjacent are basically the two legs. So I'm just going to say let's just get rid of these. I don't really like those. So let's look at the next page. The next page here is knowing the opposite, the hypotenuse, and the adjacent is going to be important because we have three special ratios. And remember, ratios are just the relationship between the sides. So it's basically like setting up a fraction to compare the sides. There's three well-known ratios that we're going to learn about, and they're called sine, cosine, and tangent. Now, you've probably seen on a calculator, you've probably seen this button before, sine, that stands for sine, and then cos stands for cosine, and then tan stands for tangent. So you've probably seen those three keys, and they relate to these ratios. So the first one here is going to be what sine stands for. So sine is always going to be sine of some angle. So let's say that let's make this A. So sine of A, so if I'm talking about angle A, sine is going to be the opposite side. It's the ratio of the opposite to the hypotenuse. So it's going to be the opposite to the hypotenuse. So sine is going to be used a lot for different types of problems in the future. But for right now, instead of us just saying, well, tell me the opposite to the hypotenuse, tell me that ratio, instead we just say sine. So it's just like a well-known, it's almost like a definition. So sine, if I say tell me sine of A, well, that means you go to angle A and you tell me the opposite and you divide it by the hypotenuse. That's just what it means. Same thing for cosine. So if I say cosine of angle A, means I'm starting with angle A and I'm going to use the adjacent this time. So it's going to be the adjacent side to the hypotenuse. So instead of me saying, okay, look at acute angle A and tell me the adjacent to the hypotenuse, I just say, tell me cosine of A. So when you do sine, cosine, and tangent, it always has to be of an angle, and then that's going to tell you your ratio versus if it's sine, cosine, or tangent. So tan, if I say tan of A, so meaning I'm starting here, this is going to be my opposite. So tangent stands for the opposite over the adjacent. So it's the ratio of the opposite side to the adjacent side with respect to that acute angle. So again, if I say tell me tan of A, I mean take the opposite and divide it by the adjacent. Now, if you look down at the bottom, there's this acronym down here that's called SOHCAHTOA. So what this stands for, it's an acronym to help you remember these three ratios. So sine is opposite over hypotenuse. So see how it's SOH. So sine opposite hypotenuse. Cosine is CAH. So cosine equals adjacent over hypotenuse. And TOA, tan, equals opposite over adjacent. So it's just a way to help you remember which ratio goes with which name. That's basically the way to remember it. So let's look at some examples. So for this next one here, it wants us to find these different ratios. That's all it's asking us to do. So if it says find sine of A, that means I'm going to be going to angle A, and I'm going to be labeling my sides like we did on the very first page with respect to angle A. So the opposite is going to be the side across from it. So this is going to be the opposite. The adjacent is going to be the side next to angle A that's not the hypotenuse, and the hypotenuse is the longest side. So if I'm saying find sine of A, well, that's your SO. So it's SO, remember, SOHCAHTOA. So SO stands for, let me write it a little bit differently. SO stands for opposite over hypotenuse. So sine equals opposite over hypotenuse. So sine of A is going to be the opposite side, so it's going to be 12 over the hypotenuse, which is 13. Then if I'm looking at cosine of A, well, here's my acute angle. Cosine is the cos, so it's cosine equals A over H, which means cosine of A is equal to the adjacent side, so A, which is adjacent, over the hypotenuse, which is 13. Tan of A is TOA, so T equals O over A. So opposite is 12 over the adjacent, which is 5. So that's the first part. Now if we switch that and we look at angle B as our reference angle, so now I'm going to look at angle B, which means this is no longer my adjacent, it's actually going to be my opposite. And this is no longer the opposite, it's now going to be the adjacent. The hypotenuse will stay the same because you're not looking at the right angle. The right angle stays in place, so the hypotenuse will always be in the same spot. I'm going to cross off this angle so you know I'm looking at B, here's my opposite, here's my adjacent. So sine is so O over H. So opposite is 5 over the hypotenuse is 13. So basically when I say sine of B, I'm saying tell me the ratio between the opposite side and the hypotenuse. That's what sine of B means with respect to angle B. If I say sine of A, I mean tell me the opposite to the hypotenuse with respect to angle A. So see how those are different answers? It's because I'm switching my acute angles. Cosine is ca, so adjacent over hypotenuse. So adjacent is going to be the 12 this time. If I switch the angle, hypotenuse is 13. Again, you should see that these angles, or not these angles, but these ratios are the same. because we switched the angle, so the opposite of one became the adjacent of the other. Same thing here. Those are the same because the opposite of one angle is the adjacent of the other acute angle. And then for tangent of angle B, tan is TOA, so opposite over adjacent is 5/12. So for tan, these just flip. Those are just reciprocals of each other. So that's kind of the relationship. If we look at the next example here, very similar, where you're going to be coming up with these different things, and it's asking us, are the triangles similar? So are the triangles similar? Yes. They're similar by angle because we have two sets of angles marked, so meaning angle A is equal to angle D, so the two acute angles are congruent, and we have right angles. So if they're similar, that means the sides are proportional. Which means if I take the same ratios of one triangle, they should be equal to the same ratios of the other triangle. Meaning, if I do sine, cosine, and tan of one triangle, it should equal sine, cosine, and tangent of the other triangle if the angles are congruent. So I'm going to write SOHCAHTOA down. So for sine, it's going to be, sine is O/H. So opposite. So if I look at A, my opposite, here's my hypotenuse, here's my adjacent. I'm going to just write these words out here a little bit. The hypotenuse I don't have though, but maybe you recognize this as one of our special right triangles. So this is a 10, 24, 26 Pythagorean triple. You could do Pythagorean theorem if you wanted to find that. So I could have done 10 squared plus 24 squared equals C squared. And if you solve for C, you end up with 26. Now, you might have just saw that that came from a 5, 12. This right triangle would have to have a side length of 13 for the hypotenuse. So basically what I did was I just times 2 to get to each of the sides. Or you could have done Pythagorean theorem. So then when I go to write sine of A, well, sine of A is the opposite, so 24 over the hypotenuse. And if I reduce that, so 24 divided by 26, I end up with 12/13. If I compare that to sine of D, so here's the opposite, here's the adjacent, here's the hypotenuse. Sine of D is opposite, so 12/13. You see that they are the same. So they're exactly the same. The reason why is because the triangles are similar, so the sides are proportional. So the sides between any right triangles that have congruent acute angles, the sine, cosine, and tangent of those angles are going to be equal because the ratios between the two triangles have to be the same. So you're talking about comparing the same two sides. The sine is the same two sides of both triangles. So your ratios are equal to each other. Really, if you look, when I reduced it, the only difference was in sine A versus sine D was these were double, and it's because this was dilated with a scale factor of 2. But when you reduce it, it's the same ratio in the end, and it's because the triangles are similar. So if we look at cosine, this will hold true as well. So 10/26, adjacent over hypotenuse. If you reduce that one, so we have 10/26, so we get 5/13. Look at cosine D, adjacent over hypotenuse, so the same. Tan A is going to be opposite over adjacent, so 24/10. If you reduce that down, you end up with 12/5. If you look at tan D, which is opposite over adjacent, so it would be 12/5 as well. So in the end, the ratios are the same because the triangles are similar because the angles were congruent. So the whole point of this is what can be said regarding these trig ratios of the corresponding sides with these two triangles. They are equal because the acute angles are the same. So sine, cosine, and tangent give or are equal to sine, cosine, and tan of congruent angles. So meaning if I take sine of the same angle, it's always going to be the same, even if one of the triangles it came from is bigger, because the triangles will always be similar.